A warm greetings to all. I am Dr. Gomati, Professor, Department of EEE, K.S.Rangasamy College of Technology. In this session, I am going to discuss about time response analysis. What is response? Response is nothing but output. What is time response? Time response is the output which depends upon the time. So, consider any particular output of any particular system. It consists of two responses, transient response and steady state response. What is transient response? Transient response is nothing but response during which transient state occurs. Steady state response is nothing but the response during which steady state occurs. So, for any particular output C of t is equal to the transient response as well as the steady state response. Usually we represent C of t is the output, that is controlled output C of t, and we represent the reference input as R of t. So, the controlled output is combination of the transient state response as well as steady state response. So, the controlled output C of t is equal to CTR of t plus TSS of t, that is transient response, transient state response plus steady state response. So, transient response occurs when t tends to infinity, that is limit t tends to infinity, CTR of t equal to 0. So, ideally the t value is infinity in practical. Steady state response is the part of the time response which at that time the response will be steady value. It reaches the steady value when t tends to infinity. So, standard test signals, there are 4 different types of standard test signals which are applied in the control system. First one is the step input, ramp input, parabolic input and impulse input signals. What is step input signal? Step input signal signifies the sudden changes in the input. Ramp input signifies the constant velocity. And parabolic input signal signifies the constant acceleration. Impulse input signal signifies the momentary shock. Next we will see about the what is step input signal, what is parabolic, what is impulse and what is acceleration signals. First we will see the step input signal. So, step input signal is sudden change in the input. So, this is the graphical representation of the step input signal. So, it suddenly changes the input to R value here. So, in a mathematical representation we can represent the input R of t is equal to R into U of t. R is the step value of the step input signal. So, R of t is equal to R into U of t when t value time is greater than 0. So, when time is less than 0, the input signal will be 0. So, the signal signifies a sudden change in the reference input R of t at a time t equal to 0. So, when time is less than 0, the input signal is 0. When time reaches t equal to 0 or greater than 0, it suddenly increases to R value. And Laplace transform of the step input signal R into U of t is given as R by S. And we can see the unit step input. Unit step input means the step value will be 1, that is R equal to 1. So, the input suddenly changes to the value magnitude is equal to 1 when the time reaches t equal to 0. So, R of t equal to 1 when time is greater than 0, then R of t equal to 0 when time is less than 0. So, for the Laplace representation of the unit step input signal is 1 by S. Next we will see the ramp input signal. Ramp input signal signifies the constant velocity. So, here in ramp input signal the output, the input is changing with respect to time, linearly changing with respect to time. So, R of t is equal to R into t when time is greater than 0 and R of t, the input ramp signal is 0 when t is less than 0, and it is called a constant velocity signal. The Laplace transform of the ramp input is r divided by s square, or by s square. And unit ramp input, so in a unit ramp input the ramp value will be 1, that is r of t equal to t when time is greater than 0, and r of t equal to 0 when time is less than 0. The Laplace transform of the unit ramp input is 1 by s square. Next is parabolic input signal. So parabolic input signal signifies the constant acceleration. So here this graphical representation shows the parabolic signal, and here r of t equal to r into t square by 2 when t is greater than 0, and r of t equal to 0 when t is less than 0, and Laplace transform of the parabolic input signal is r by s cube. And next one is the impulse input signal. Impulse input signal signifies the sudden shock. So here in this graphical representation we can see that this impulse signal will be a value that is equal to 1 when t equal to 0, and the impulse signal will be 0 for the time is not equal to 0. So the impulse signal we can get the input only when time equal to 0. For remaining value of the time the impulse signal will be 0. So here the Laplace transform of the impulse signal is 1. Next we will see the definition of the transfer function and the polynomial of the transfer function. Transfer function is nothing but the ratio of output to the ratio of the input when with 0 initial conditions. So transfer function is equal to C of s by R of s. So the C of s is nothing but Laplace transform of the output, R of s is the Laplace transform of input, and we have the numerator polynomial and denominator polynomial for the controlled output and input. So g of s equal to the numerator polynomial is bm s bar m plus and so on plus b naught divided by s bar n plus a bar n minus 1 s bar n minus 1 plus up to a n. So here we have a numerator polynomial and a denominator polynomial. When we solve the numerator polynomial we can get the poles, sorry zeros. When we solve the denominator polynomial equal to 0 we will get poles here. So k is called system gain and n is the type of the system. And next is pole 0 plot. So in S plane we can plot the poles and zeros here, that is called pole 0 plot. So when we equate the transfer function polynomial, numerator polynomial is equal to 0, we get the zeros. When we equate the denominator polynomial equal to 0, we get the poles. So from that poles and zeros we can plot in the S plane and we get the pole 0 plots. So here we have a S plane, S equal to sigma plus j omega. Sigma represents the x-axis, that is x-axis, and j omega is the imaginary axis, nothing but the y-axis. And next is characteristic equation. So characteristic equation can be obtained by equating the denominator polynomial of the closed loop transfer function to 0. So we get the transfer function. So in the previous slide we can see the transfer function of the closed loop system. So if we equate the denominator polynomial equal to 0, we get the characteristic equation. So here we can see one example to find out the poles, zeros and pole 0 plot and characteristic equation. So for example, consider the transfer function transfer function equal to k into s plus 6 divided by s into s plus 2 into s plus 5 into s square plus 7s plus 12. For this we are going to find out the poles, zeros, pole 0 plot and characteristic equation. So already we discussed that what is poles. Pole is nothing but equating the denominator polynomial of a closed loop transfer function to 0 and we get the roots of that equation, that is called the poles. So here we have the denominator polynomial as s into s plus 2 into s plus 5 into s square plus 7s plus 12 and equate it to 0 and we get the 5 values of s, nothing but S equal to 0, minus 2, minus 3, minus 4 and minus 5. So we have 5 poles and we can locate here, and the poles are represented in the cross marks. So here we can plot the S plane, x axis sigma and y axis, imaginary axis j omega. Poles are represented by cross mark, and we can mark the poles 0, minus 2, minus 3, minus 4 and minus 5. Next is zeros. So here zeros. So here zeros can be obtained by equating the numerator polynomial to 0. So in numerator polynomial s plus 6 equal to 0, then s equal to minus 6. So we can mark in the pole 0 plot, and zeros can be represented in the circle. So here we can mark the circle, s equal to minus 6 is the 0. So this is the pole 0 plot of the given transfer function. Next is characteristic equation. So characteristic equation is nothing but equating the denominator polynomial of a closed loop system is equal to 0, and we can simplify the denominator polynomial and we can get the characteristic equation as s power 5 plus 14 s power 4 plus 71 s cube plus 154 s square plus 120 s equal to 0. So we had discussed about the what is time response, what are the different standard input signals, what is pole, what is zero, what is characteristic equation, what is transfer function, and how to find out the poles, zeros, pole zero plot and characteristic equations. Thank you.